Alright, now we are in the graphs of simple harmonic motion. Okay, so this is the first question. The graph of displacement against time for a particle with mass 10 gram. Okay, we have mass here. Okay, something we should highlight first. Okay, we have mass here. In a simple harmonic motion is shown below. Okay, we have a displacement time graph. Okay, displacement time graph. What is the amplitude, the period, the angular frequency? Okay. So the question asks for amplitude. Okay, amplitude, the period, and the angular frequency is omega. Okay. So all right. So what information can we get from this displacement time graph? Right. First of all, the displacement, maximum displacement is 0.2. This is the maximum displacement. So this maximum displacement is amplitude. This is the amplitude. And this one, this is how many wave? Okay, we have gone through, okay, between crest and crest, this is one period. So this is actually two period. So these are the things we can get. So, and be careful with the unit. This unit is meter, this is second. So take note of the unit. Yeah, sometimes this can be cm. Then the amplitude is cm. Sometimes this the unit can be millisecond. Then our period can be in millisecond. So these are the things we should be careful. Okay. So we know, okay, so from here we got the amplitude. So first of all, the amplitude is 0.2 meter. The unit is meter. Okay. And then the period. Okay, because this has two waves. From crest to crest, one period. Another crest to another crest, another period. So there are two period, two wave. So two period. This is two period equal to 4 second. The unit is second. So we use second. So be careful with the unit. So we get a period. Period is 2 seconds divided by 2. Okay. So that's the answer. Now how about the angular frequency? Angular frequency is omega. So just use formula. We already have the period. So just use the period. Omega is 2 pi over period or 2 pi f. So we have period, we use the period. So 2 pi divided by period, which is 2 seconds. So the answer is pi radian per second. Pi radian per second. Or the answer is 3.14 radian per second. Okay, 3.14 radian per second. Okay, we got the omega. Now, on the same axis, sketch graphs. You want graphs to show the variation with time. Okay, with of the kinetic energy. Okay, actually, there are some typo here. Variation with this is our syllabus should be with displacement. Okay, there are some typo here. I'm sorry. Okay, what we should learn, the graph is sketch graph to show variation with displacement. Okay, the following energy: kinetic energy, potential energy, and total energy. Okay, so we need to show the graph between the energy with displacement. Our syllabus is using displacement. Okay, I'm sure there is graph with time, but that's not in our syllabus. So we should learn the graphs or between energy with displacement. Okay, now okay, how to draw? This actually the shape is like this. Okay, so but we need the label. Yeah. Okay. The total energy is constant. Okay, the total energy is always constant. The potential energy is actually the smiling graph. Potential energy is 0 at the equilibrium. Okay, this is the displacement. Okay, this is the displacement. The x-axis is the displacement, and the y-axis is the energy. Okay, displacement. So when displacement is 0, the potential energy is 0. Okay, but potential energy, the elastic potential energy is maximum at the amplitude. Okay, kinetic energy is maximum at the equilibrium, but 0 at amplitude. Okay, we need the label. We need the label. So the maximum displacement is A. And this should be negative A. Do we have the A amplitude? Yes, we have 0.2 meter. So here we put 0.2 meter. Okay, the unit is meter. Okay, this one should be negative 0.2 meter. All right, that's the displacement. And this, the maximum here, the maximum value here is half m omega square a square. Actually, half m omega square a square is the value of total energy. The total energy is always constant at half m omega square a square. This is also, the total energy is also the equal to the U maximum and also equal to the K maximum. You see, when U is maximum, this is the place where U maximum. You see that? U maximum at here. U maximum at here. U maximum here, it is equal to half m omega square a square. When U maximum, it is equal to half m omega square a square. When K maximum also equal to the total energy, which is half m omega square a square. See, K maximum at here. See, the K maximum at this point. K maximum. K is 0 at this point. K is 0. K is 0. Yeah. The potential energy. The potential energy is 0 at the equilibrium. Right? The K maximum is equal to K is maximum at the equilibrium. So we need to find this maximum value, half m omega square a square. We need the value to label here also. If not, we will lose mark of no label. So what's the total energy? Okay, what's the total energy? So half, we have the mass. Do we have the mass? Yes, 10 gram. Oh, 10 gram. You need to change to kilogram. Okay, so the mass, you need to change to kilogram. Mass is, you need to change to SI unit. Divide by 1,000, so you have 0.01 kilogram. Okay, so our mass is 0.01 kilogram. Now, what is our omega? Do we have omega? Yes, we have omega, which is pi or 3.14. So it is in SI unit per second. Okay, so that is 3.14 square. Do we have amplitude? Do we have amplitude? Yes, our amplitude, which is this one. Amplitude in SI unit, meter also. Okay, not cm. Good. Amplitude in meter. Amplitude in meter. So, okay, amplitude 0.2. Just put there 0.2 square. Okay, what's our answer? 1.97 exponent negative 3 joule. Yes, that's our total energy. That's our total energy. Okay, so label there. Label there. So our total energy there is label there. Yeah, 1.97 exponent and negative 3. Negative 3. Okay, so that's our total energy at the maximum value. Okay, the total energy here. And then so you need to label when you draw the graphs. Remember, you must have the label with the value at the maximum. Here also label with the value. The unit also already has already put in the axis there, joule. Okay, joule. This one in meter. And Yeah, that's all. All right. So, okay. So, hope you enjoy these videos. Stay tuned for the next one. Bye.